As you've learned, there are two main data models for GIS data, vector and raster. Additionally, GIS data comes in many file formats. So when gathering data for a project, it's common to acquire data from several sources. It's also common for the data to be in several different file formats as a result. In this lab, you'll create a project geodatabase for the Gifford-Pinchot National Forest in Washington State. First, you'll normalize the data. This means that you'll put all data sets in the same coordinate reference system and clip them to the study area boundary. Lastly, you'll put them all into the same file format, a spatial light geodatabase. In this first task, you'll familiarize yourself with the lab data and will begin to normalize that data. Here I have QGIS Browser open, and I've navigated to the Lab 2 data folder. There are 8 vector layers here. There are 4 shape files, a couple KML files, and then there's 2 coverages. And one interesting note, the coverages were just introduced in the last lab, and in that case there was just one coverage. Here we have 2. We have Admin Forest and Ranger District. When you have 2 coverages in the same folder, they both share the info directory. That means that the Admin Forest attributes and the Ranger District attributes are in this info folder. That's just a side note about this file format. So while I'm looking at this data, I can look at the coordinate reference system for each layer, and this will tell me which layers need to be saved to a new coordinate system. So I can click on the watershed HUC4 shapefile. The metadata tab comes up, and I can see that this is in UTM zone 10. So this data set is already in the correct spatial reference. KML data, by default, is always in a geographic coordinate system with an EPSG code of 4326. It's the only coordinate reference system the file format will support. I can click on Trails next. That again is in UTM. Roads is in UTM. This is a vegetation shapefile. And I can see this isn't something different. Proj equals AEA stands for Albers Equal Area. So this is in some kind of Albers Equal Area coordinate system. If I expand the Ranger District coverage and click on the metadata XML, I can see that this is in that same Albers Equal Area coordinate reference system. And I'll expand the Admin Forest layer, select that, and see it too is in Albers Equal Area. So I've got several data sets that will need to be reprojected into a new coordinate reference system, several that are already in the desired coordinate reference system of UTM. So I'm going to bring up QGIS Desktop, and I'm going to add the Admin Forest coverage. So I'm going to click the Add Vector Data button, change my source type to directory, and the source to ArcInfo binary coverage. And I'll click the Browse button and navigate to my Lab 2 data folder. And I'll select the Admin Forest folder and click Open. I'm going to add the Polygon feature class. Select that and click OK. And there's my forest boundary. So again, this layer is in the Albers Equal Area coordinate reference system. I can open up Layer Properties and go to the General tab, and I can see that it's in a custom Albers Equal Area. There's no standard EPSG code associated with it. Since it's in a custom CRS and there's no EPSG code associated with it, I can't reproject it on the way into the database. So first I'll have to save this out to a shapefile in the desired CRS and then import that into the database. So I'll click OK, and I'll simply right-click on this and choose Save As. Click the Browse button. I'm going to switch to my Lab 2 data folder. I'll call this Forest Boundary. Then for the CRS, I'm going to browse for that. And the EPSG code for UTM that we're using is 26910. So I'm going to type that into the filter to easily locate my coordinate reference system. Select that and click OK. And choose to add saved file to map. And I'll click OK to reproject this. So I both reprojected it and converted it to a new file format, a shapefile with the same operation. I don't need this original coverage anymore, so I can right-click on this and remove it. And I can double-click on this reprojected layer and see that it is indeed in the desired coordinate reference system. So I've taken care of the first data set. You'll repeat this same step for the Ranger District coverage. The only other data set that was in Albers equal area was the vegetation shapefile. So I'll click the Add Data button, choose File as the source type, click Browse, change the filter to Esri shapefile, and find the vegetation data set. Click Open, then Open, and I'm going to right-click on this layer and Save As, and save it out to a new shapefile. Just going to call this Vegetation, click Browse for the CRS, choose UTM Zone 10, choose Add Save File to Map, and click OK. This is a slightly larger data set with hundreds of polygons, so it takes a little bit longer for QGIS to reproject it. Once it's done, I can remove the original, since that was a raw intermediate data set. And I'll just turn this off so that it doesn't have to keep redrawing every time I refresh the screen. Now I'll add the National Forest roads and trails and watershed data sets to QGIS. These were all shape files, and they were all in UTM. So they don't need to be reprojected. But when I add them, I can see that they overlap. They go beyond the spatial extent of the forest. So these data sets need to be clipped to the forest boundary. Clipping data to the study area boundary allows you to maximize your efficiency. You're not going to be rendering data that's beyond the scope of your project, and you won't be processing any data beyond the scope of your project. Here I'll clip the watersheds layer. I'm just going to go to the vector menu to Geoprocessing Tools, choose Clip. I'm going to choose the input vector layer as watershed. The clip layer is forest boundary. And I'll call the output watershed clip. Choose Add Result to Canvas and click OK. You can see the data processing. Again, this is a fairly large layer, so it will take a few moments. When it's done, I can click Close, and I can remove the original watershed layer. And now I've got my watersheds clipped. And you'll clip the other two, the trails and the roads, in the same fashion. Okay, so I've gone ahead and clipped the forest roads and the forest trails to the study area boundary. And I've taken the initial steps to normalize the data. The last two layers, rivers and lakes, are in KML format. And remember that all KML data layers are in a geographic coordinate reference system with an EPSG code of 4326. Since their CRS is not custom and has an associated EPSG code with it, these can be reprojected when importing into the Spatial Light database. So I don't need to reproject those ahead of time. So all my data is now prepared for migration into my geodatabase, and in the next task I'll cover how to create a new Spatial Light database.